Okay, here's the next particular paper from Pixi Maths, paper 3 for the 2023 Edexcel paper 3. So this is my paper. We'll see how quickly we can get through this one. Okay, so straightforward question to kick off with. Just to, can you draw the picture? What does it look like? So on a centimetre grid, draw the front elevation. So we're drawing this front elevation. If I make any mistakes on this paper, it's because I haven't actually seen the paper before. So what I'm going to do, I'm just going to go 4 across. What have I got a scale? 1 centimetre, 1 metre. So 4 centimetres across, 2 centimetres up, 2 centimetres up. The middle's going to go up 4, and then you're going to make the house picture of the front, aren't you? So here we go. So you can draw it any way you want. So 1, 2, 3, 4. 1, 2, 1, 2 there. And then I need to go 4 from the centre to make the roof. So there's the roof bit, and there's the other roof part coming down there. Pretty straightforward. 4 marks. I don't know why there's 4 marks for that question. I can't imagine that will be the case in the GCSE exams. This is a high T paper, isn't it? Just double check. Yep, it says higher. That's a bit of a weird question to kick off with. Right, here we go. Nice, lots of things going on here. Customers making decorations. Each decoration makes a candle and a holder. I've seen this type of question before. So Caroline buys some candles and some holders in each of the packs. There are 30 candles in a pack, and there's 18 holders, and you're going to buy the same amount. How many candles and how many packs? So it's basically a lowest common multiple question. A bunch of ways of doing it. One way is just to write out multiples of 30 and write out multiples of 18 until you get the same amount. So we've gone with 30, 60, 90. 18 is 19 times 5, so 18, 36, 54, 72, and then 90. So we can actually just make 90 packs, can't we? Catherine buys exactly the same amount. How many candles? And so you could have other amounts, but they're just going to be multiples of 90. So you could have go for 180. How many packs do we need? So the candles are in packs of 30. So there's 3 packs there. And how many? That one. There's 5 packs in this one. So that's 3 packs of candles, 5 packs of placeholders. Pretty straightforward. It looks a bit blurry. That means just a little twiddle with the thing. Yeah, there it is. It's a bit better. Next one, you use all the candles, all the holes. How many decorations can she make? Well, she makes 90, doesn't she? Because that was the number that we ended up with at the end. Now, you could have different answers to this one. You could have 180, 270, 360. Any multiple of 90 will work. Number 3 is just going to draw this graph. Quite a straightforward line graph. One way to draw the graph is to put a table together. So the XY table. Put your numbers in from -1 to 3, so -1, 0, 1, 2 and 3. And I always recommend when you fill the table in to come backwards, so start at 3 and come backwards. The equation is 4 lots of the number plus 2, and I like to put brackets there, and then I can just slip the number in the brackets and figure out what's going on. And if you're not sure, use your calculator, because this is a calculator paper. Put 3 in there, get 4 3s are 12, plus 2 is 14. Put the 2 in there, 4 2s are 8, plus 2 is 10. 4 1s are 4, plus 2 is 6. What I'm noticing now is the pattern, it's going down by 4 every time, so this one's going to be 2 and this one's going to be -2. Now you can run the numbers through if you want, or you can look for a pattern. I knew it was going to be a line graph at the x graph. Why it was x graph is just a line. X squared would be the u, x cubed is, I don't know, it's like an N shape, I guess. So here we go with a line. So -1 across, this is always across, and this one's up and down. I don't know why I'm saying this, it's a high T paper, you should know how to plot points. So -1 and -2 is here. 0 was 2, 1 was 6, and then there, and then there. And then it's a case of just getting a ruler out. I'm going to put a protractor somewhere down here. What's in this pencil case? Oh, I thought I had one. That's annoying. Can't see my protractor anywhere. But it's just a case of taking your ruler now and just joining those points together, isn't it? So it's just do a freehand. Please don't do a freehand in the exam. Remember, if you're in the exam hall and you don't have equipment, put your hand up and the invigilators will bring your equipment over, because they want you to be successful as well. Number 4. Okay, so we've got containers filled with water, and we're probably looking for what the picture looks like. So the graph represents height of the water in the container as a function, and what's happening under the water. So the water starts filling up, it fills up really quickly but really steadily. So it's either this one or this one. And then it starts to slow down, doesn't it? And it's starting to slow down at the same rate. So I'm probably going to go with this thing here for the picture. So I'm going to go with, what I'm going to do? I'm going to go that one. Okay. That's how I'll go. It fills up with water, so the height's increasing, the volume's increasing. Yeah, I'm going to go that one. It's one of these two. Probably the second. Number 5. So we've got pie chart. There's 5 red lines, drew 5 matches. So where's drew? You draw 5 matches, so there. So what can we do now? Well, we can say 45 degrees. 45 degrees represents 5 matches, and we want 72 degrees. So we can just do a quick jump down to 1 degree, and then we can just jump down to 72 degrees, divide by 45, and then times by 72 would be a way to get there. If I can find a calculator, that would be useful. Here we go. So on the calculator, I'm just going to do 5 divided by the 45, and then times by the 72, get the answer 8, and there's my answer for the 1. I'll just put that on the diagram. I always like to write things on the diagrams. Cecilia says the pie chart, blue dolphins won more matches than red lions. That's because this pie chart here is much bigger this side, and this one's only small. This is always a trick question. We don't actually know how many people are in this pie chart. So the answer to this one, is she correct? We don't know if she's correct. We don't know. We don't know, as we don't know how many games blue dolphins played. Okay, so that's just a question. Next one, we've got some parallel line things going on. We're going to try and find x, so let's just whack some angles on. I've got to give reasons all the time here. Oh, it's a bit of a pain. So I'm going to go into this angle here, which I'm going to write in as 44 degrees. So this angle here, so I'll just label it number 1 because the letters aren't very good on here. We can say this is 44 degrees. So where are we going? So number 1, it's angles at a point on a line add to 360 degrees, and then I'm going to go inside the triangle to get this one down here. So that's what's that going to be. So let's go for the 180 job. So 180 in this little triangle here. So 180 take away 42 take away 44. So that looks like 94 there. So I'm on 94 in here. So I've got 94, so I'll call that number 2. So it's the second one I worked out, number 2. Angles in a triangle add to 180 degrees. And then we've got 94 down the bottom here, so that's 94 for number 3. You could probably name them all. If they had more letters on, you could name the angles better. But number 3 is vertically opposite angles. Vertically opposite angles are equal. I'm going to go from the 136 all the way down to here, or from this 44 down to here as well. Let's go that way, I think. So I'm going to go down to number 4. And the reason I'm going to do that at number 4 is if I use the 44, that one, so I can come down here like this, and I can get to this angle down the bottom here with that Z sort of shape. But you do need to know the proper name, so you can't call it the Z angle, it's actually called an alternate angle. I could have also went with this one, so going down the C shape, and there would be co-interior angles or interior angles, or sorry, you can't see it, co-interior angles there, or you could call them allied angles, I believe you call them. I always call them co-interior. So this one's 44. Co-interior add 180. The Z angles are the same, the alternate angles. So this is number 4. So number 4, I was going with alternate angles. Alternate angles are equal. So that's that one. Now I can get to here. This is going to be 42. I could have come down that way, couldn't I? 42 degrees in there. This is the problem with these things. You can often do them other ways. So once I got that 42, in fact I could have just went from 42 to here and then to there. So it seems I've done lots of different work, lots of work that I didn't need to do, and it just shows I haven't done this paper before. So anyway, so just keep going. So number 5, I've got number 5, and I'm going to just go with the angles in this triangle at the 180 job. So that's simple. So angles in a triangle add to 180 degrees, and then this angle here must be 138, because at this point on the line we're going to add to 180 again. So x equals 138, and the last answer I'm going to give, so number 6, I've got angles at a point on the line. Angles at a point on a line add to 180 degrees. Okay, so one of the tricks to working on angles is just start off and just work out any angle you can. You don't have to like look for one particular way. You might spot a quicker way later on, like I've just spotted I can get there in 2 goes, there, and then straight on to the straight line job, so alternate angles and then straight line. But writing information on the picture is going to get you there eventually as well. Okay, so this question is just a straightforward calculator question. Let's see what happens on the calculator. So press the fraction button, 0.004 times 0.05, and on the bottom 0.002, and I've got an answer of 1 over 10. So press SD, and it's got 0.1, so that one is 0.1, and in standard form that's just 1 times 10 to the power of minus 1, minus meaning in the decimals, and there's a 1 0, or actually dividing by 10. It actually means 1 over 10, but never mind. Number 8, what we've got now, probably a comparison one, so best value question. And our best value, you want to get to the same amount usually, so it's easier to do the money, I think. And it's a calculated question, so instead of having to think too much, I'm just going to try to get down to £1 for each one and see how many tea bags I get for £1, and then the more tea bags I get, the better it's going to be. There's different ways of doing this question, but that's how I'm going to do this one. So I'm going to go to £1 there, so £1 I'm just going to divide by 5, so 240 divided by 5, let's just double check it's 48, so 240 divided by 5 is indeed 48, so you're getting 48 bags. This one go down to 5 to 1, so we're trying to get to 1. This time we're dividing by 4 to get down to 1, so we divide by 4, and then 4 into that one is 50 bags, so that's better value so far. And this one divided by 3, so we divide this by 3, 160 divided by 3, a bit more awkward, 160 divided by 3 is 53 point, so that's to get to £1, wasn't it? And that's 53.3 bags. Okay, and that's a recurring 3. So clearly this box C is the best value for money, so just call it box C. And that's how I'm doing that question, just get down to 1. It's a calculator question, so you don't have to worry about the numbers. Looks like we've got interior and exterior angles. I've just done this for my year 10s. So what we're going to do, I always start with the interior angles. There's formulas for it, n minus 2 times 100, but I like to do a 3-sided shape in a triangle. It'll have 180 degrees in a triangle, and every time you add a side on, so 4 sides, you just add 180 on, so it's 360 in 4-sided shapes. 5-sided shapes, 5 sides is going to go to 540, just adding 180. 6 sides is going to be, add 180 is 720. 7 sides is going to be, add 180 is 900, and then 8 sides, we add another 180 and we get 1080, and that's as far as we need to go. If we look at the shape, these are regular shapes, which just means all these angles are the same. So we've got this hexagon over here, 6 sides, so 6 sides is 720, and that means each of the angles, if you divide that by 6, you'll know this angle in here, and I believe that is 120. Let's just double check. So 720 divided by 6. There's no point not using your calculator and getting that wrong with you just thinking it's going to be something. Octagon, 8 sides, 1080, so we've got octagon here is 1080. So 1080. Regular shape means they're all the same, so just divide that by 8 and you'll know each angle around the corner. That's 135, but let's just double check. So 1080 divided by 8 is 135 indeed. Okay, and then the last angle is this one, which is just angles around the point. So now I'm doing 360, take away 120, take away 135 equals calculator 360, take 120, take 135. 105, and that's our angle X. Okay, angles around the point 105. Now just note on the top, it does say you must show all your working out, but it doesn't say you have to give reasons. So there's not much writing. It's just show your working out means just give your numbers up. That's it. You can do them different ways, but that's how I'm doing it. All these questions you can probably do in different ways. I'm just showing you how my first thought on doing it. It's the first time I've seen this paper. Question 10, I'm going to try to get the P. I can see 2 triangles. I'm going to split them out into 2 separate triangles. So this first triangle here, 5 and 12, so 5 and 12 there. This is obviously a right angle triangle, and we're just going to use Pythagoras to get to the side. This one here, the missing side. So this is the opposite. The right angle is C. So as we know, C squared is 5 squared plus 12 squared. which is just use your calculator, no point doing anything extra work. So 5 squared plus 12 squared is going to be 169, isn't it? Yep, 169. And then C equals a square root of 169, which you can just use your calculator for to show that, a square root of 169, and you get 13 for that side. So this side now is 13, okay? So now we know this side up here on the diagram is 13. Now when I look at the second triangle, let's go with this triangle again. So second triangle, we've now got 63 in the top corner, we've got P over here, and we've got 13 at the bottom now, so that's 13. Now with right angle triangles, I'm only going to use Pythagoras or SOHCAHTOA usually. They're the two things we go for. Now the we've got opposite is the hypotenuse. This is a SOHCAHTOA question, so hypotenuse over there. Opposite is down the bottom here, it says the opposite side, and this is the adjacent, but we don't know anything about that and we don't really care about it. So out of the SOHCAHTOA things, we're looking for SOH, CAH and TOA. We're looking for one with the hypotenuse in because we need to find P, and one with the opposite in because we know that one. So it's got to have H and O in it, so it's going to be SOH. My triangle, SOH triangle, just pick up the middle thing, then fill it in. S is sine of the angle, so 63. The opposite side is 13 actually, and then P is the hypotenuse. So this little triangle tells me that P is equal to 13 divided by sine 63. And let's go for that one. Now notice there's 3 significant figures up here, so I'm looking for the first 4 numbers in this question. So 13 divided by sin of 63 for equals 14.59, then it just runs off forever. I write 4 down because I want to round to 3, so 3 significant figures is going to be 14.6. Not happy with the focus, it's a bit naff, isn't it? Oh, that's a bit better. I don't know, it's a bit weird because when you move it around it just changes focus. Anyway, number 11, nice little Venn diagram. Filling this in, this is the universal set, so that means the only numbers you're going to put in are from 1 to 16, and then we've got to put multiples of 3 in A and multiples of 5 in B. So let's go through it. So number 1 is nothing, number 2 is outside, number 3 is obviously a multiple of 3, number 4 is on the outside, number 5 is in B, number 6 is in this one, number 7 is in here somewhere, out here, number 8 is out here, number 9 is a multiple of 3, number 10 is a multiple of 5, number 11 is outside, number 12 is a multiple of 3, 13 is nowhere, 14 is nowhere, 15 is in both of them, and then 16 is nowhere, and that's it, 1 to 16. So you just put them in one at a time, dot them in the right place. Next one, we've got probably there's a number, one of the numbers chosen at random, we've got P, and then we've got this funny looking sign. This one is the intersection, so that means where do they intersect? Intersection. Okay, the other one is the U, and that means the union, union, and then the other one is a little dash actually, so A dash means not in A. So that's a little dash. Not in A would be, if you look at these numbers in A and you just look at everything outside there, so these lot here and these two, the union would be everything in the Venn diagram part itself, so these bits, and then the intersection is just the 15. So there's only one number out of the 16 numbers in the intersection, so the probability is 1 out of 16. Next one. Write this thing 0.354 in a fraction as its simplest form. So the routine just goes n equals, so 0.3545454, so the 5 and 4 is repeating. 2 bits repeating, so I multiply by 100, so I get 100 lots of the number is equal to, move the decimal point in twice, so 35.45454 goes off forever. We now write the number back underneath again, so line up the decimal points this time, so 0.3 and then 5454. Do the take away so we can get rid of all the recurring parts. All these are going to disappear, and we're left with 4 take away 3 is 1, and then the 35 from nothing, and now over this side we're left with 100n, take away n is just 99 of them, so 99n. Now we've got 35.1, so we need to get rid of that point just by multiplying by 10, so we get 990n equals 351, and we finish with n equals 351 over 990. Now a little cheat here is, because I can't look, see that it cancelled down, it probably does, it divides by 9, doesn't it? If I just got the calculator and type it in as a fraction, so 351, over 990, like that. Press equals, and the calculator will do all the simplifying for me. So my final answer is 39 over 110. Okay, so you can cheat a little bit at the end to cancel your fraction down. Next one, we've got the old, what are these called? Frustum questions. So you see lots of these questions in past papers. By removing, a frustum is made by removing a small cone. It says your volume of your cone. We've got density, so density, we've got a DMV formula going to kick in at some point. I'm pretty sure I've seen this question somewhere else on one of the past papers. Glass has a density of 2.5, work out the mass of the frustum, give your answer to a degree of accuracy. Now we've got, let's just draw the two cones, because we've got really two cones to consider, haven't we? So we've got this first cone here, and then we've got the bigger cone where we're going to chop it off, so we're going to do things on these things. We've got, was this a question on another particular paper, and they put it on this one because it hasn't been used yet on the paper 3, maybe that's why we've seen it. So we've got 12 going all the way across here. Okay, we've got a total height here of 15. So there's the total height of this thing. That's from that bit. Now the height of the little cone is going to be 15, take away this 10, so that's going to be 5, isn't it? So the height of my little cone over here is going to be 5. Now the thing about the cones, they are similar cones. So the 5 to 15 is multiplied by 3, 15 to 5 divided by 3, 12 divided by 3 is going to be 4. So the diameter of that little thing is going to be 4. We can work out volumes now. We can work out the volume of the big one, volume of the little one, volume of the big one, and see what else we need. So the volume is the little formula up here, 1/3 of pi r squared h. So we've got 1/3 of pi r. The radius of this one is actually 2, so we've got 2 squared times by 5. So that's that one. And then this one's going to be 1/3 of pi times 6 squared times by 15. Okay, make sure you know the radius is not the diameter. This is the diameter of your circle, the radius is actually 6, and the radius on that one's 2. Doing the work on this one, we've got, what's that going to be, 20 over 3, so we've got 20 over 3 pi for that one. This one a little bit harder, so we've got, well, it's going to be a nice number actually, isn't it? 36 times 15, it's going to be 180, and then divide that by 3. So we've got equals 180 pi over here. Okay, and then we've got the, what else have we got? We can now work out the frustum, can't we? So the frustum's volume, this thing, is just that one, take away that one. So if we just do on the calculator, 180 take away 20 over 3 is 520 over 3 pi is the volume of our frustum. Okay, so what else have we got? So there's our volumes. Frustum is made of glass. The glass has a density of, so there's our density, there's our volume. We can just go with the DMV triangle now and work out the mass. So we've got DMV now for our frustum, DMV. We've got a density of 2.5. Mass we don't know, so M is what we're looking for. And we've got a volume of 520 over 3 pi. You can just change them to regular numbers if you want. You just tend to lose a degree of accuracy when you're doing it. So I like try to keep it as accurate as I can. And the calculator's doing all the work anyway. I've just got to understand that's just a regular number. Yeah, so that's why I've left it like that. So where we're going, so we've got, these are going to be multiplied together because they're just next to each other in our little triangle. So we're going to multiply them together to get a mass of 2.5 times 520 over 3. And we need a pi somewhere, so let's put a pi there. And then we get that number there, but degree of accuracy, so we can press SD now. So I've got 1000, so it's equal to 1361.35 ... I'm going to word one decimal place, so it's 1361.4 to a degree of accuracy. Now I chose one decimal place mostly because they give me the density to one decimal place, so I'll just stick with something that they give you in the question. Next one, sure, this is going to be this one. So the way I expand triple brackets is I'll just expand this one to kick off with, and then I'll put that one back into play after I've done that one. Now my method for expanding brackets is a smiley face. So my smiley face goes 3x times x is 3x squared, minus 2 times 1 is minus 2. Underneath I get minus 2x. Underneath that one I get 3x, just multiplying along all these lines. and the bottom two simplify down to just plus an x down there, so minus 2 plus 3 is 1. So this expansion is 3x squared plus x minus 2. 3x squared plus x minus 2, and then I've got the front bit is 2x plus 1 into that equals. So that's how we do this. So we just expand one set and we put the other one back in. It doesn't matter which one you start off with, you could have done these two and then put that one in the end. Now I'm just going to multiply everything by 2x, so 2x times 3x squared is 6x cubed, 2x times the x is plus 2x squared, and 2x times minus 2 is minus 4x. So that's the 2x done. Now multiply everything by 1, but I'm going to write underneath, and I'm going to line up the powers of x. So 3x squared is going to go underneath this one. So we get plus 3x squared plus 1 times x is plus an x, and 1 times minus 2 is minus 2. Then we finish off by just putting this together, so simplifying that bit. So add them together, you get 6x cubed. We get 5x here, 5x squared here, minus 4 plus 1 is minus 3x, and then I've got a minus 2 at the end, and then just double check, that's what they asked for, that's what I ended up with. I'm good to go for 3 marks. Excuse me. Jesse did a survey of the number of cups of coffee teachers had in his school and drunk yesterday. The table shows a frequency, it looks very low for coffee in the staff room. So there's one person had 2 cups, 3 people had 3 cups, 5 people had 4 cups, 8 people had 5 cups, and 5 people had 6 cups of coffee. That's what I'm reading off the table. So your total number of tables is just your total frequencies, total number of teachers, sorry. So what we got, I'll just do it in the calculator, I'm going to try thinking about. Let me start adding them up on my head. 1 plus 3 plus 5 plus 8 plus 5 equals 22 teachers in the story there. The mean number of coffees, so now I need to know how many coffees there are, and this is where you're just going to multiply these things. So 1 times 2 is 2, 3 times 3 is 9, 5 people had 4 cups, that's 20 cups being drank, 8 people had 5 cups, that's 40 cups have been drank there, and 5 people had 6 cups, so they've drunk 30 cups altogether. So how many cups have we drank altogether? Just add them up. So 2 plus 9 plus 20 plus 40 plus 30 equals 101. So it's 101, that's the total number of cups. This is the total number of people, so divide by 22, and then you get your answer. So divide by 22 of 4.590, I'm going to write the whole thing here, 4.590, and we'll put dot there, because that's what it says. If it's not too big on the calculator, there's no reason why you can't write the whole thing down. What are we doing here? So it looks like we're going to do a completing the square job. So completing the square, the way we do this one is we just half this number here. So we get, we write x plus, and then half of that number is 4. It would be minus if it said minus. Then we're going to write squared, and we take away. And we take away whatever this number is squared. So I'm going to take away 16. So that's the actual completing the square bit. And then you've got this minus 4 floating off at the end. So now you just throw the minus 4 in there. And then we just tidy up a little bit, so that bit's going to stay the same, that bit's going to change to minus 20, minus 16, and minus 4 is minus 20. So x plus 4 squared minus 20. Hence or otherwise, find the quantity of the turning point. So the whole point of completing the square is to find the turning point. So this y here, so now we've got y equals, and that equation is the same as that one, and that one is the same as that one, so y is equal to this thing here. So it's x plus 4 squared take away 20. The whole point of here is we can find a turning point because we can find the smallest this can possibly be is actually 0, because when you square anything it becomes positive. So if you make this a negative number, if you say x is minus 10, then minus 10 plus 4 is minus 6, and minus 6 squared is 36, so now you're back in the positive world. So the smallest this whole thing can be is when you've got to make it 0, so that's x plus 4 equals 0 is the smallest it's going to get to, which means x equals minus 4. And when this is 0, y is going to be minus 20, because nothing take away 20 is minus 20. So your quantity turning point, so y equals minus 20, is going to be minus 4, comma, minus 20. And that's why we, or one of the reasons we complete the square, is to find turning points. Next one. Okay, so I've got an area of a triangle, so I need to know my formula is a half AB sine C is the area of a triangle. It's not a right angle triangle, so it's not base times height divided by 2. This is the angle, so I'm going to call this angle C, which would make this side C, and then angle A can be down here. That can be angle A, I guess, and this can be side A, this can be angle B, and this could be side B. Okay, remember capital letters for the angles, little letters for the sides. don't worry about their annotations, their labels on the sides. You can actually cross them out and put them wherever you wanted to. Like A could be here for me if I wanted it to be, and B could be that angle, and these things I would just actually cross out. I don't like it when they put on their own labels on. Anyway, now it's just a case of using the formula. So we've got a half, and then we've got A, which is, for me, 13, B, which is 9, sine of 50, and then just grab your calculator and go for the answer. I want 3 significant figures. Remember, the trick for 3 significant figures is write down 4 and then round after that. So I've got 0.5 times 13 times 9 times sine of 50 equals, so I'll write down 4, 44.81, whatever, and then round off 44.8. 44.8 is where it rounds to. And that's the area, metre squared, yeah. Calculate the length of AB. AB is, let's just draw that thing again. So we've got this picture, we have this picture going on. We have 13 here, 9 here, 50 here. This is A, B, and C. You know, it's asking me to find this length. This is a cosine rule job. The cosine rule is A squared equals B squared plus C squared minus 2BC cos A. So that's your cosine rule. Just run your numbers. So A squared equals B squared and C squared. Now I'm labeling this differently now. So this is A and this is going to be capital A now. So notice how that angle isn't this one at the top. Okay. This is for the cosine rule job. So that's angle A, that's little a. B and C can be either side, so obviously will be there and C there. So I've got 9 squared plus 13 squared minus 2 times 9 times 13, and then I've got cos of 50, which equals, grab your calculator, 9 squared plus 13 squared, take away 2 times 9 times 13, and then cos of, what is it, cos 50. Cos 50, press equals, so that's 99.5876, whatever it's going off to be. Now I need to do the square root. Notice I'm just writing lots because I'm not into the wrong phrase, but now I'm thinking about 3 significant figures, so the next bit I'm going to go write 4. So now I'm looking for the square root of that, 99.5876 thing, which equals, and then just square root your answer, so square root A and S, press equals. Now I'm writing 4 down, so 9.979 wherever it goes off to. And the 3 significant figures, now you write 4, round to 3, 9.98 is the length of AB. Next one. Circle, write down the coordinates of the centre of the circle. So all GCSE questions are going to be of centre of circle 0, 0. When you get to A level, you find another formula for the circle where your centre is not 0, 0. The exact length of the radius, well, the formula for a circle is x squared plus y squared equals r squared. So the radius of this thing is just the square root of that bit, so I'm going to go for the square root of 5, and it says exact form, so I'm just going to leave it as the square root of 5. That's all that one is. Point P is on the circle at 1 minus 2, on the circle x squared plus y squared equals 5. Work out the equation of the tangent of the circle. So there's a bit of work going on here. We're starting to get into the harder questions now. So let's have just a quick sketch. So we've got this circle here where it's got a radius of 5. Don't care what the radius. A point 1 minus 2. So 1, let's say 1 minus 2 is there. So there's 1 and there's minus 2. And we're trying to find out the equation of this tangent. Okay. Now what we can work out is we can work out the gradient of this thing here, which is the radius. And when you get A level, they call this the normal. For some weird reason, don't know how to do that. Anyway, so the gradient of the radius is the rise over the run job. So it's rising up 2, or it's actually going down 2, so it's rising up minus 2 and it's across 1. So the gradient of the radius is equal to minus rise of minus 2, because it went down, over 1, which equals minus 2. So the gradient of the tangent is the negative reciprocal of this thing. So it's already negative, so the tangent's obviously positive. You can see it's going upwards there. And then the gradient is going to be the reciprocal of 2, which is a half. So the gradient of the tangent equals a half. This gives me equation. Now the at A level is you develop another formula for the equation of a line, but the one that we mainly use for GCSE is y equals mx plus c. So we've got y equals a half x plus some constant, which we don't know just yet. But what we do know is we do know it's going to go through this point. So 1 comma minus 2 is a point. So this means when x is 1, y has to be minus 2. So let's put it in. Minus 2 equals half times by 1 plus c. And then you can just bring that over here. So you've got minus 2, take away this half. So let's just do it on the calculator. So we've got minus 2, take away 0.5 equals minus 5 over 2. So c equals minus 5 over 2, which means my equation is going to be y equals a half x minus 5 over 2, and then that's the end of that question. Okay, and then you can manipulate this thing and just change the formatting of the equation if you wanted to, but there's no point in doing that one. Virus on a computer is causing errors. We haven't got much to do left. An antivirus program is run to remove the errors. Estimate of the number of errors at the end of t hours is this 106 times 2 to the minus t. Work out an estimate for the number of errors on the computer after 3 hours. So I guess we're just going to put 3 in there. So we've got 106 times 2 to the power of minus 3 equals, so it looks a bit weird that question, but it doesn't turn out to be that bad actually. 206 times 2 to the power of, well, we're on minus 3. Make sure when you're doing your negative thing for the negative power that you're using this button, not the take away, not your subtraction button down here. Don't use that for your negative numbers, use this one for your negative numbers. That just equals 53 over 4, let's just put that in that one, 13.25. Work out, so 13.25, just go with that one. 13.25 errors, so you could say there's 13 errors if you wanted to. Well, yeah, you could say 13, I'm not bothered about that bit. Explain whether the number of errors of the computer ever reaches 0, and the answer is no, it doesn't. No. The reason it doesn't is because obviously that's a positive number, and sorry, this is a positive number, and this can't be 0. Okay, well, you've got 2 to the power of something, you can't put 2 to the power of anything and get to 0. Even if you put 2 to the power of 0, anything to the power of 0 is always 1. So this never ever reaches 0. Okay, no, since 2 to the minus t cannot equal 0. Okay, and that's why it can't be that one. Flipping over. Last questions. Clive wants to estimate the number of bees in a beehive, so we see lots of these questions. He catches 50 bees and he marks each one with a hive. Now we don't know how many bees he's got, so let's just call it B. So he's actually caught 50 out of bees, and that's how many are actually marked. He then lets go. The next day he catches 40 and 8 of them are marked. Okay, so we've got 8 out of 40 are marked. Now what I've got to try to manipulate, I'm going to try and manipulate this 8 and change it into a 50. So it's just a case of equivalent fractions now. Now the first thing I'm spotting is this actually cancels down, dividing by 8 and 1 out of 5, so that's the same as 1 out of 5. And then if I times that by 50, so I'll get 50 out of 250, and this means that this 250 B is 250 bees is his estimate for the number of bees in the hive. What assumption have I made? So a common question is, what happens if the dye is being rubbed off or something like that? Then the number changes. So assumed that no markings have rubbed off or something along those lines, rubbed off. Okay, so that's why I'm going for that one. Next one, prove algebraically that the difference between the squares of 2 consecutive integers is equal to the sum of those 2 integers. Prove algebraically the difference between the squares of 2 consecutive. Right, let's start. So 2 consecutive integers. So we call the first integer n, and the next one n plus 1. Okay, so that's 2 consecutive numbers. So 4, and then this will be 4 plus 1 is 5, or 10. 10 plus 1 will be 11. They're consecutive when they come straight after. I have to square them both, so let's go for that one. So I need to do this one squared and this one squared. I'll have to do a double bracket job on that one, and I'm going to assume you can just, no I won't. So we've got n squared for the first one, and then we've got this one is n plus 1, and then bracket n plus 1, and when you do whatever method you're using, so the smiley, I'll do the smiley face, n squared plus 1, and then underneath you're going to get 1n, underneath that one you're going to get 1n, and this 2 makes 2 n's. So this lot is n squared plus 2n plus 1. So that's just expanding that brackets, right? So I've got the squares of them both now, there and there. Prove the difference. What's the difference between these two? It's that one, take away that one, it's just going to be that bit, isn't it? So n squared plus 2n plus 1 minus n squared is 2n plus 1, isn't it? Okay. Now what I've got to show, so I've done the consecutives, I've done the squares, I've found the differences. It's equal to the sum of these two integers. So now I've just got to add these two integers together. So these are the two integers right there. So I've got n plus 1 equals 2n plus 1 again, doesn't it? Okay, these are the same. These are the same. Smiley face, QED, whatever you want to write at the end. And that's the Pixi paper. Some things missing. I can't remember any circle theorems on paper 2. I imagine that will be a big factor in these things. But you should be doing lots of predictive papers at this point. Well, not lots. There's only, I think, about 2 or 3 out. Only 2 at the moment. That's it, folks. Good luck on Wednesday.